Alright, here's my wacky graphic organizer. My title is If Similar, Then Proportional. If Proportional, Then Similar. This is actually math lingo too. Another way to say this is using math symbols is as such. So I could have just written my quote like this. It would have meant the same exact thing. Okay, so my central theme here is triangles. See, it went off to the left quite a bit, but let's just kind of take a quick walk through. So I started with congruence because that's what we knew about first. We knew if we use transformations, such as translation, reflection, we would end up with congruent triangles, right, where all the lengths remain the same. So it doesn't change size proportionally. Each side length remains exactly the same, which would keep it congruent. Now I also drew this line going through. Congruence of angles leads to similarity. So here I also have dilation, which links up with transformation as well, because we know if we transform a triangle by dilation, the triangle will stay similar. Just like that, if you remember, we had the center of dilation here, and then we had all these points. Let's say it's A, B, C, and this were A prime, B prime, C prime. We know that they're similar triangles. And what would we find? We would look for and find the scale factor by taking the length from here to here and dividing it from the length from the center of dilation to that first point. Dividing it, that will give you the scale factor. And there's a symbol for it. So off from similarity, we have the similarity theorems, which you guys all noted. Angle, angle, side, angle, side. Have some representations here. This first one on the left, remember, we know that these interior angles, it's called the vertical angle theorem, tells us that those two orange angles are congruent. And since these opposite sides, this side and this side, are both parallel to each other, and this line here passes through both of them, we know those blue angles are congruent. And then obviously with our other ones, we know side, angle, side. We need to make sure those sides are proportional. And we know that angle is congruent. And then side, 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 we use all three sides. Make sure that those are proportional. So we also have theorems. Theorems does attach to the similarity theorems, but these theorems over here are not necessarily related to the similarity theorems, called the proportionality theorems. So we learned about angle bisector. We know that if we have a triangle and we have this line here that bisects this vertex, so these two angles are congruent, we end up with the following proportion. M over x is equal to n over y. We also know we could have written it like this. M over n is equal to x over y. We've seen that that works as well. Now, besides the angle bisector, we also have triangle proportionality. If we have a triangle, we have a line parallel to the third side. We know that it breaks up the side lengths proportionally. As you can see, a over x is equal to b over y. We've seen before, we can also say that a over b is equal to, can you guess? X over y. So that proportion works as well. So that's triangle proportionality theorem, midsegment theorem. Here's our midsegment theorem. We know that if we have a triangle and line A here breaks up this line and this line into even parts. So you can see those little index, the marks, the orange marks and the blue marks. They say that those are equal congruent parts. So we know that A is a midsegment, which means that it's half the length of the third side of the triangle, B. You can see that here. Make sure you understand, since B is equal to 2 times A, we also know that A is equal to 1/2 B. Something you should also know. We know that A is half the length of B. Furthermore, with another theorem, we have geometric mean. That seems to be one people get caught on the most. We first learn the altitude hypotenuse. So if you have a right triangle, so that's this one right here, and we create an altitude, we construct an altitude, so that's a line going from the vertex of the 90-degree angle and perpendicular to the hypotenuse. So the hypotenuse here is A plus B, that whole long length there. That creates a right angle and therefore creates 3 triangles in total. 3 triangles which are all similar, and we know since they're similar, they hold proportionality. So the one we used to find the value of the altitude, in this case it's x, is we said that A is to x as x is to b. When we cross multiply that, we get x squared equals a times b, and we take the square root of both sides, we get x equals square root ab, a times b, and that's exactly what I put right here. I put that shortcut. You know that x is equal to the square root of a times b. So it's altitude hypotenuse. On the other hand, the more difficult one to remember is the altitude leg. So again, we have the same thing going on here. We have a right triangle, which is being broken up by an altitude. Here's that altitude. And because breaking this triangle up into 3 similar triangles, which are all proportional, we have different ways to write. Now I wrote the shortcuts here, but we know we could say, let's see, y, in the case below, y would be equal to, and I'll start by creating the proportions. So we can say, check it out, here's the hypotenuse of the big triangle, so that's a plus b, I'll write that out, a plus b, and then we have to look at the hypotenuse of the smallest triangle. See how that's the hypotenuse of the smallest triangle? So we'll say is to y as, now check it out, back to the big triangle, if we take the smallest length of the big triangle, which is y, and compare it to the smallest side of the smallest triangle, which is a. So we get a plus b is to y as y is to a. When we cross multiply, y squared is equal to a times a plus b. And remember, we want y by itself, so we take the square root of both sides. The square root gets rid of the square, and we get y is equal to square root a times a plus b. And that's the shortcut I wrote right here. Z is similar, right? Z is on this side. So instead of using a, we end up with using b, as you can see right here. But a plus b here is the hypotenuse. That's something to definitely remember. Seems to cover about everything we covered. There's obviously small details that are left out, but Hopefully this helps.